Good morning. My name is Hans Stetzer. I am a junior computer science major here at Furman University.
And I'm Max Norman. I'm also a junior computer science major here at Furman University.
And today we will be demonstrating and overviewing an app called Confluences, developed by Michael Fataruso and Philippe Gibonelli. So Confluences provides a simulation environment for different situations relying on two things: fuzzy cognitive maps and agent-based modeling. In this app, we ask, what is a fuzzy cognitive map? And a fuzzy cognitive map is a combination of fuzzy logic and cognitive mapping, or the use of directed graphs. And it's a way to represent knowledge of systems which are characterized of uncertainty and complex processes. So it's composed of nodes, and each of these nodes have a value representing a concept. And these values range from 0 to positive 1. And they're also connected by edges. And remember, this is a directed graph, so these are also weighted edges. And these edge weights range from -1, representing a negative causal impact, to +1, representing a positive causal impact. And when the edge weight is 0, there's no impact. So let's say this is a negative causal impact from 0.4 to 0.8, and a positive causal impact from 0.6 to 0.8. And what's unique about a fuzzy cognitive map is that since it's showing these uncertainty of these concepts, it's showing this uncertainty over time, in discrete time. And it's updated by the following equation. So we have vi of t plus 1, which is the value of concept I at the next step, equals, and this is enclosed by a transfer function, which I'll get into later, plus the current value, vi of t, plus the summation of your current value of the connected concepts, vj of t, times the causal strength. So this may look somewhat foreign to you, but it's a lot simpler than what it actually is. So we have vi of t represented by this node right here. So let's say 0.8 plus the summation of all of these nodes and their causal impacts. So 0.4 times -1, so minus 0.4, and then 0.6 plus 1. So 0.8 minus 0.4 is 0.4 plus 0.6. And that way, we get a result of 1. And that would be the value at the next step. However, say that this value was 9, for example, our result value would be 1.1. And earlier, we learned that these nodes or concepts can only be represented in the value from 0 to 1. And this is where our transfer function comes in. So essentially, what that does is it takes the result of the value, which is 1.1 in this case, and it condenses it in this transfer function and normalizes it to fuzzy cognitive logic, or the fuzzy logic used in fuzzy cognitive maps. So typically, this is done in a sigmoidal fashion, and that's representative of a hyperbolic tangent. But that's not tremendously important on understanding this concept, and I won't get into it into too much detail. So next, we will go into how agent-based models influence different situations and provide a simulation environment given fuzzy cognitive maps as input. Great. So agent-based models. In agent-based modeling, a system is modeled as a collection of autonomous decision-making entities called agents. And each agent individually assesses its situation and makes decisions on the basis on a set of rules. And at the simplest level, an agent-based model consists of a system of agents and the relationship between them. And when I think of a system of agents and a relationship between them, I immediately go to a finite state machine. And a very simple finite state machine, say we have state A, state B. And in order to get to state B, we have to trigger an event that takes you to state B. And in order to get back to state A, an event also has to occur. And say we never leave state A, it's demonstrated by this third event here. Now, this may look similar to a fuzzy cognitive map, but these A and B states are more kind of thematic ideas in this context, and these events are not necessarily causal weights, but more so triggering relationships. So if we take a further look at this, these agent-based models can be used for flow diagrams, for evacuation, traffic, customer flow management. It can be used in markets for the stock market, shop bots, software agents, and so on. But in this context, we're using an agent-based model to provide a simulation. So an agent-based model incorporates neural networks, evolutionary algorithms, or other learning techniques in more advanced models, or kind of a hybrid attempt. And this app actually uses a hybrid attempt, but unlike using a neural network, we actually use fuzzy cognitive maps to achieve this. And a paper written by Philippe G. Bonelli, modeling the spatial and social dynamics of insurgency, kind of hints at this. So say you have a concept of the United States, Syria, and Libya. And each concept represents a fuzzy cognitive map of several edges, nodes, causal impacts, and causal weights. And not just composed of 7 nodes, but let's say hundreds of thousands of nodes and edges. And these concepts get really dense and trigger multiple events and have multiple steps, multiple stages, and by themselves somewhat represent an idea, but what we're concerned about is the relationships that exist between them. So we look at this situation of insurgency here, and we look at civil war, and we want to see how does it impact the US? How does it impact Libya, Syria, and how do they impact each other? And you'll see here in this finite state diagram of this finite state machine representing an agent-based model that Libya and Syria are cycling back and forth, and the USA is influencing Syria, influencing Libya. And basically, it's doing this based off of having certain nodes in the fuzzy cognitive map influencing others, and by the same token, certain nodes in the fuzzy cognitive map being influenced by others. And so what we have here are multiple concepts, multiple ideas, or multiple influences influencing each other inside an agent-based model, and this is where the name confluences come from. So now that we have a basic fundamental understanding of all the concepts that go into this app, I'm going to turn things over to Max Norman to give you an actual demonstration of the software. hand things over to Max. Thank you.
Cofluences provides a graphical user interface for users to develop and analyze fuzzy cognitive maps, which are able to be used to represent agents within an agent-based model. Once the FCMs and ABMs have been created, users can run simulations which can provide distribution and trend analysis for their data. Now in the following video, we will see how users create FCMs within Cofluences. Users may create FCMs from scratch, or they may load FCMs that were created earlier. Nodes can be added and connected with their edges through simple click and drag controls. Clicking on the edges will allow us to assign weights, and once we have created our nodes, we can assign what kind of values we want in them, whether they be uniform, constant, or normalized. Some nodes may need to stabilize before others, and some nodes can influence others, and others will simply influence nothing. Now, in our next video, we will see how the agent-based models interact with these FCMs. Within Cofluences, you are able to select the properties for your ABM, and once you've selected the percent of the population or the number of agents you want to be influenced, you're able to run simulations and see how all these different FCMs will interact with one another. And once you have it all set up, you can be given a graphical representation that shows the influences over steps in time, as demonstrated by this graphic coming up now. After both the map connections and agent connections have been established, simulations can be set up to run the data and see how the agents represented by the FCMs may interact. This phase lets the users analyze how the structures of their FCM may change over each discrete step. We choose discrete steps over actual time since it better allows us to analyze the turning points within our data, since there may be some steps that are more crucial for a particular node than others. The overall goal of Cofluences is to provide an intuitive interface for users to generate and analyze FCMs so they may be used in agent-based modeling.
All right, well, hopefully that provides a concise understanding of our app, and while still in development, Cofluences is very useful in the sense that we can provide a simulation for an environment, whether it be an economic decision based off of different markets and different influences, or a more socioeconomic political decision based off of several countries, several different opinions, and several different figureheads. And we'd like to give thanks to Philippe and Michel for developing this app, and we want to see where it can go.
Thank you.